is 1 and y is 2. Why it will definitely be commutative is we know that 1 plus 2 must definitely be equal to what? 2 plus 1, and that is what? 3. You can see now. So that is why when we have this kind of scenario, then we say that has exhibited, or that operation has exhibited commutative property. Then also 1.2 is also equal to 2.1, which is equal to what? 2. That is also commutativity. That means commutativity is possible under the operation addition and multiplication. Now, these are the UTME questions under the binary operation. So it is very pertinent to note that these are the questions that have been extracted from the UTME series. So each one is a UTME question. So let's see these questions and the approach to solve it within the shortest possible time. So let's see the first question. A binary operation star is defined by x star y equals to x raised to power y. If x star 2 equals to 12 minus x, find the possible values of x. So in this situation, we can see that from question 1, which can be denoted as figure 1.4a in this respect. So look at the operation x star y equals to x raised to power y. So what it means is that since we are now given this equals to 12 minus x, so what it simply means is that it's our y that is raised to power, So automatically we can write that as x. Y is taking the position of 2. So 2 will definitely take the position of y here. So it will be x squared equals to 12 minus x. So let's try and restructure this. We have x squared plus x minus 12 equals to 0. So this has taken us to what is known as what? Quadratic equation. In the quadratic equation, we use this to multiply this, giving us minus 12x squared. So we look for two factors of this, that addition or subtraction will give us the one in the middle. It will be no other one than plus 4x minus 3x. So here we have x squared plus 4x minus 3x minus 12 equals to 0. So we try to dissect what we have here. By dissecting this, we have x into x plus 4. And this one will be minus 3 into x plus 4 equals to 0. So we have x plus 4 into x minus 3 equals to 0. Then x plus 4 equals to 0, or x minus 3 equals to 0. And we have x equals to minus 4, or x equals to what? Plus 3. So x equals to minus 4 or 3. So we'll go to our option and see the one that fits in. So in this first case, we have 3 minus 4. So that would definitely be option B. So the second question says that if a binary operation star is defined by this, find this. So in this situation, we have the operation x star y, and it's defined as x plus 2y. So we are now given this operation. So in this situation, we have to solve this. The best way to solve this, in order to arrive at the correct answer, is to solve the one in the bracket first. If you are solving the one in the bracket, which is 3 star 4, where our x will be 3, our y will be 4. So in this situation, we have what's our x? 3 plus 2 into our y plus our 4. So that will definitely give us 3 plus, this times is 8, that is 11. So we now have 2 star 11. So we follow the same trend. X is 2, y is 11. So we have 2 plus 2 into 11. Then we have 2 plus 22, and that is 24. So the answer to that very question is 24. So we go to our option and see the one that fits in. That's option A. So we move to question 3. A binary operation plus on real numbers is defined by this. For 2 real numbers, x and y. Find this. So we look at the operation. Operation is the most important aspect of this. So our operation here is xy plus x plus y. So in this situation, we have 3 plus operation minus 2 over 3. So we simplify this. Our x is 3, our y is minus 2 over 3. So in that situation, anywhere we see x, we replace it with 3. Anywhere we see y, we replace it with minus 2 over 3. So this is x here. That will be 3 times minus 2 over 3 plus x, 3, plus what is our y? Minus 2 over 3. So in this situation, we have 3 here 1, 3 here 1. So 1 times minus 2, minus 2, plus 3. Plus times minus, minus 2 over 3. So let's make everything fraction. And we look for the LCM. What is the LCM in this regard? It will definitely be 3. 1 and 3, 3. 3 times minus 2, minus 6. Plus 1 in this, 3. 3 times this, 9. Minus 1 in 3 in this, 3. 3 in 3, 1. 1 times this, 2. So we have minus 6 minus 2 plus 9 over 3. Minus 2 minus 6 minus 2. That is definitely minus 8. Minus 8 plus 9, 1 over 3. So the answer will definitely be 1 over 3. So we go to our option and see the one that fits in. So it will definitely be option D for question 3. Then question 4, we have if x star y equals to x plus y squared. Find this. This one is not different from the one we saw in the question 2. So in that situation, we still follow the same trend. Our function is the most important here, and our function here is x plus y squared. So that means in this situation, I have what? 2 star 3 into star 5. And I said earlier that let's attend to the one in the bracket first. So we have to attend to this one first. So 2 star 3, where our x is 2 and y is 3. So definitely, what is our x? 2 plus 3 squared. So automatically we're going to have 2 plus 9, and that will definitely be 11. So we come back and say 11 star 5, where our x is 11, y is 5. So in this situation, we have 11 plus 5 squared. What's 5 squared? 5 squared is 25. So 11 plus 25, that will definitely be 36. So the answer to this very question will definitely be 38, and that is option D. A binary operation star defined on the set of integers m and n. Full stop. Find the inverse of minus 5 under this operation if the identity element is 0. So in this situation, we need to recall the concept of what? Inverse. We know that it is said, or it should be noted that if x belongs to S, then there is a possibility of x, that's inverse, x inverse to also belong to S. If and only if x inverse star x is equals to x star x inverse, which is now equals to what? Our identity. So this is the relationship. That is, if this is even belong to S, if S is even a real number, set of real number, if x belongs to S, that means inverse of x will also belong to what? The real number. And that's what you have. So in that situation, I think a relation has been given to us in this respect. If it is not given to us, based on question 5, the relation is not given to us. So that means we have to look for a binary operation star defined on the set of real number m and n under the operation m star n, which is the same thing as m plus n plus mn. That is the operation that it should be noted that this is the operation for this particular one. So in that situation, we have x star x inverse will definitely be x plus x inverse plus x inverse must be equal to our identity. So in this situation, what is our x? That is element of the real number. That is minus 5 plus our x inverse plus our, this is our minus, this is minus 5x, because our x minus 5x inverse equals to identity. What's our identity? 0. So here we have this scenario. So if you are talking about this, automatically we are going to have minus 5, then this and this will definitely give us plus x inverse minus 5x inverse equals to what? 0. So minus 5, this one will give us minus 4x inverse, which is equals to what? 0. So here we have, by collecting like signs, we have minus 4x inverse equals to 5. When this one goes to the other side, we will divide both sides by minus 4. So by dividing both sides by minus 4, we are going to have minus 4 divided by minus 4. Minus 4x inverse divided by minus 4 equals to 5 divided by minus 4. So this one will give us, so we'll cancel, and we'll have x inverse equals to minus 5 over 4. So we go to our option and see the one that correlates with that, and that will definitely be option A. Now, question C, binary operation. So we have this operation A, triangle B. A operation B is the same thing as A plus B plus 1. So in this situation, for any real numbers A and B, find the inverse of the real number 7 under the operation triangle if the identity element is minus 1. So this one is not different from number 5 that we saw. It's the same trend, so same pattern. So here we have, it is if x belongs to S, it implies that x inverse